So it's going to be interesting. So 4 nights, please come back. And the first night is tonight a amazing 5 presenters, and I encourage you guys to have a more open discussion after their presentation, because it's not official one of those lectures. I want you to start think about it, because I don't know too much about AI. I mean, you can Google AI, but what do you know? But maybe, hopefully, after 4 nights, you get inspired and start think about it. That's the point of tonight.
Good, that's great. Oh, hey. So we're from Avalanche Studios, which is a video game company here in New York. This is Niklas Norin. I'm Malte Skarupke. I'm an AI programmer. He's an actual AI designer, so that's relevant because AI and design. And yeah, we actually on the scale of like that nested AI chart, we actually all the way on the outside we're not doing machine learning or like deep learning or any of that. We're just doing simple AI, old school AI. So I'm going to talk about how we use AI. So we make, or I'm going to talk about the technical side. He's going to talk about the design side really quick. Yeah, so we make open world games. Like this is Just Cause 3, our last title, where yeah, we have a open world where you can explore, and we have lots of people in there. I took a picture of a town square with some people standing around. And the main thing that we have to worry about in this is that we have like a pretty complex world, but we only have 33 milliseconds per frame to make a decision. So every 33 milliseconds, we have to put a picture on the screen. So everything has to run really fast, and that's the main thing that that I'm thinking about as a programmer all the time. And so the classic thing to do is, if you have a complex situation in AI and you have little time or little resources to do it, is you have to make the world as simple as possible. And so the classic example of that is a dishwashing robot, where I just Googled for this. And the reason why dishwashing robot is a good example, because this guy is clearly about to drop the cup and going to create a giant mess. Or it just seems likely that he might drop the cup, and then you might think maybe he should be able to clean up after himself. But then he's just going to knock over more things. It's just going to be a total mess. So if you want a dishwashing robot, the way you do it is you have to create a world in which it is very simple to wash dishes. And the way you solve that is inventing the dishwasher. So on the left, that's a terrible way to make a dishwashing robot. On the right, that's a great way to make a dishwashing robot. And we're doing a similar thing in our game, where we have this AI world that's kind of like behind the whole world, which I created the overlay here of like the nav mesh, the navigation mesh. This is the same thing seen from above, where I try to hide all the objects that the AI doesn't actually see. So all they see is these blue lines and red lines, and they know that they can cross the blue lines, they cannot cross the red lines. So we've got these people sitting on the left, sitting on benches, but they don't know that there's a bench there. They just know that there's annotated points to walk there, and then they can play an animation to sit on a bench. These people are leaning over tables. They don't know anything about this world. They only see the red lines, blue lines, and annotations. And they can't ask what the color of a building is or anything. They don't see any of that stuff. We also have a physics world, which has like slightly more information, but I'm not showing that here, but they only get to use that rarely. Most of our decision making happens in very simple worlds. I forget what the next slide is. Oh yeah, this is my conclusion from the technical side. How we work with AI is we try to keep it as simple as possible. Most of our logic is just long chains of if-else, which we are getting pretty good at managing. We have like abstraction layers over that. And yeah, our priorities are, it has to run fast, has to be easy to change when the game changes. That's a very important thing, which prevents us from using more fancy machine learning things, because those tend to be harder to change, or they take longer to train, things like that. And the last thing is also really important. If an AI makes a choice in our game and we don't know why it made a choice, that's a bad thing for us. We have to be able to figure out why it made all the choices that it made. So this is AI from our side. We're simulating a whole world, but we are doing as much cheating as possible in order to get into the budget. And you will talk about the design side of it.
Yeah, so hi, I'm Niklas, and yeah, so I'm an AI designer in video games, which basically means that I'm a game designer first and foremost, and I've kind of like over the years I have specialized in AI. So the last 8 years or so, I've been mainly working with AIs in our game. And basically, so what I do is basically apply a lot of our, game design principles on how we choose to implement our AI. So this is mainly on a somewhat higher level, like the systems that Malte was talking about is kind of like the low-level systems that we have. And so I'm more focused on the kind of like the behaviors that our agents do or our systems work and so on. And basically also looking at mainly that what the purpose of our AI in the game that we're trying to do. And that, of course, depending on the game we're making, it can vary quite a lot. But most of the times it needs to be deterministic, because we are not really there to like simulate a world. We are there to give the player a good experience. So basically, a lot of things in our games is that, or they don't need to be, or they should not, in some cases, be as intelligent and efficient as possible. We need to make them look like that. They should be perceived like that by the player, so that the player feels really smart when they outsmart them. And it's really, we also need to look at like, yeah, the gameplay purpose. So if you're making a stealth game or something like that, they can't be as good as a human should be, because then it would be a very frustrating experience for the player. And we're also looking a lot of like how basically if our AI agents take decisions that the player don't understand, it's basically no real need for them to take those decisions. And a lot of times that also often leads to the player perceiving them as unintelligent, because the player don't understand the actions that they are doing. So, and yeah, that's it very shortly about what we do in terms of AI in video games.
This was on a web page, right? So how do I
think you need to put it up.
Okay, that's fine. I use Chrome.
Yeah. Or
Okay, cool. Hi, I'm Francis, and thanks for having me today. I'll just quickly introduce myself and just kind of give a quick tour of some of my work. So I am the co-publisher of this magazine called The New Inquiry. It's a magazine of cultural criticism and technological criticism. So these are some of our more recent issues. I'm also a research in residence at New Inc., which is the New Museum's incubator program. And I'm also a professor at the New School, where I teach about digital psychological warfare and programming and stuff. So this is probably the most relevant project for this particular talk. It's this set of guides and a sort of still in progress book called Machine Learning for Artists that I worked on with this artist, Gene Kogan. He does a lot of stuff with computer vision and machine learning, a lot of generative stuff using neural networks. So this is a guide mainly to sort of get artists who have some experience with programming but don't know anything about machine learning into the field, so that they can start to pick up the basic techniques and experiment with it and hopefully generate some interesting work. This is a project I worked on as part of a residency with my friend Fei Liu called Humans of Simulated New York. What we did was we basically wrote this economic simulation based off of New York City census data of about, I think, 10 years or so. And in it, you can see there's like these tall columns. These are buildings, and each layer is a business in the world. There are 4 kinds of businesses. There are hospitals, firms that produce equipment that other businesses use, companies that produce food, like grocery stores and so on, and then companies that produce like the raw materials that these other businesses use. And then up and down these alleys, you see these shapes moving back and forth. Those are the residents of the simulation. So their shape indicates their sort of economic status, I guess their class. So spheres are business owners, cubes are people who are employed, and pyramids are unemployed people. And then they're color-coded according to race, census race categories. So the idea here is we wanted to kind of figure out some way of visualizing the kind of structural inequality that is present in census data that's reflected in it. But we also wanted to bring it to life. So each of these sort of shapes that are moving back and forth, they have their own set of behaviors and preferences. They try to find a job if they don't have one. They try to make enough money so that they can buy food. If they get sick, they'll go see a doctor if they can afford it. Sometimes they'll wait a really long time if they can't afford it, and then go when they're really desperate. So they live out their lives, and we have these charts to kind of get a picture of different sort of values of the world and so on. I don't have it pictured here, but we also added this sort of speculative fiction component to it too. So when you start the simulation, you actually can choose a few different parameters. So you can choose the level of technology in the world, you can choose the level of agriculture and food, and you can also choose the level of health. And you can kind of see how the world changes depending on these starting conditions. And then finally, with this project, we also made it so that it was interactive. So you could join the simulation on your phone, and when you join on your phone, you would get randomly assigned one of these simulated people. And then every month in the simulation, players could propose and vote on legislation, and the goal was sort of to vote on things that would help your particular citizen succeed in the world. So this is another project that was also with Faye and another one of our friends, Dan Taeyong, which was sort of building off of some of Humans of Simulated New York. So Humans of Simulated New York was simulating an urban population at the level of the city. High-rise, we wanted to sort of, Dan is an architect, so we were working with him to build a tool that allowed you to lay out an interior and then sort of attach, so these black cubes you see, or black shapes you see here, are just objects in the space, and you can sort of attach certain properties to them, like, you know, if these are couches, for instance, you could say these are really soft couches or not soft or something like that. And you'd unleash a population of agent simulated people in this environment, and then you would see how they interact with it. So the idea here was that you can kind of test different layouts of things, or like test window placement and write in behaviors that people prefer to work in areas with more light or something like that. So that was that. This is a game that I worked on called The Founder. It is, the subtitle is a dystopian business simulator. You can play it online at thefounder.biz, but basically it's set in the year 2001. You are the founder of a startup, and your sort of only objective is to grow as fast and as much as you can. And if you don't grow fast enough, your investors get unhappy and they kick you out. Of course, that happens after a certain amount of time because you can never grow indefinitely, or not in this game at least. And the idea is that by trying to stay in the game and trying not to lose, you end up making sort of the world a dystopia for everyone else. So this is one of the more recent projects. This is a project that me and two friends, Sam Levine and Brian Clifton, did for the New Inquiry, called White Collar Crime Risk Zones. So some of you may have heard of predictive policing, but that is probably one of the more insidious applications of machine learning. Basically, the idea there is that police departments will use historical crime data and then use that to make policing decisions. The problem there, as with many of these sort of more problematic applications of machine learning, is that the algorithm makes decisions based off of the data that you feed it. So if that data already reflects certain systemic biases and so on, that will also be reflected in the resulting algorithm. So it tends to just tends to reinforce existing policing patterns, existing discriminatory policing patterns. And what's worse is that now it shifts the blame to an algorithm. So police departments can say, oh, we're just doing what the algorithm tells us. There's this sort of veil of computational objectivity, and they can kind of shift the blame and burden. So they're less likely to address some of these issues. So what we did was we created our own predictive policing algorithm, except it targets white-collar crime instead of so-called street crime. And the idea here is just to show that, like, oh, how come predictive policing is never used in this kind of way? It's always used to target minority or the poor and that kind of thing. And so here you can kind of see any sort of hotbed of financial activity is also one in which white-collar crime is likely to occur. So this is meant to be a critique of predictive policing, and so a lot of the work that I'm doing now is sort of more related on trying to bring more visibility to how machine learning is being used in these ways. And that's it. Thank you.
Hello, everyone. Let me do this. Hello. So my name is Kevin. I'm a co-founder of Wearworks, and what we're developing is communication through touch. So we call this haptics. But a lot of people don't know what haptics means, but it's quite simple. It's everything that you do every day that you use your sense of touch to communicate an information. And that's what we've been developing, about what we do. So we find this to be really important because in our day and age, everybody's using the full extent to our visual bandwidth, and pretty much we're kind of confined to this. So we just want to bring some of that and offload it to touch. How it all started, I never actually give this presentation from this far back, but it all started here at Pratt. I was an industrial design student, and you may be confused by Henry and our last names, but we're not related. But he was a deep mentor that helped us launch this product from the very beginning. And I'm going to also attempt a video, which I hope works. Yep. It's probably the last time we'll show this video, actually. But.
We are Team DAHRC, a group of multicultural industrial designers focused on research and digital arts. This is our concept for a wearable haptic device powered by Intel's Curie chip, Beyond Sight.
It's not called Beyond Sight anymore, by the way.
With the proliferation of screen-based devices, visual bandwidth is reaching limitations. Wouldn't it be nice to navigate to a destination without having to look at your phone? You would naturally be able to avoid obstacles along your path. Be able to keep your eyes open for potentially dangerous situations, taking in visual information from the surrounding environment, and responding. Our research team has been collaborating with General Vibrations to find applications for high-definition haptic feedback devices. Recent studies have shown that asymmetrical vibration can create a sense of directionality in haptic feedback. Theoretically, this can be achieved with low-profile, low-cost motors that are available on the market today. Our idea is to take this technology and embed it in a wearable device. It will take advantage of the Intel Curie chip 6-axis combo sensor, accelerometer, and gyroscope to pinpoint the wearable device's orientation and physical position. Combined with the asymmetrical oscillations of 2 ERMs, or with the 3-axis combination of LRAs, there is potential for a wearable device as small as a wristband that gently guides you in the direction of an end destination. Put away your GPS. There's no need for that anymore. A user will be able to navigate towards a location while still taking in the sights and sounds of the surrounding environment. Although such a low-profile device may not be attainable for another few years, we do see there is the possibility of achieving a wearable device that is comprised of a matrix of low-cost LRAs. Sequential vibration patterns could simulate the feeling of directional haptic feedback, guiding the user toward a target regardless of the position or orientation of the wearable device. An omnidirectional haptic guidance device such as this could make navigation intuitive for, well, anyone. From helping cyclists navigate through bike trails to helping the visually impaired navigate through life. The question is, how will you experience the world where you can go beyond sight?
All right, presentation. No, I'm just kidding. So I wanted to show that video because it's probably gonna be the last time that I'll show it. That was 2 years ago, about when we first, developed the concept. And this was just a very basic design that I created as an image to entice some people. We got into a program called Next Time Maker, New York's Next Time Makers. They gave us some money with no equity exchange, which was great. That got us through the first phases of prototyping. And this was really the fun phase. We were just playing around, creating a bunch of really weird gadgetries, creating omnidirectional information, and starting to really explore how we can work with haptics as our main language and create that foundation from navigation onward to higher communication. So this was first, Henry talked about trust. We started going to these organizations, establishing trust. We went to South by Southwest and visited all the different blind organizations. And this is where things kind of start happening. I met a guy named Marcus Engel, who was an author, and he was a blind author. And he told me about some of the difficulties as a blind person navigating through the cities and how difficult it is that Google Maps doesn't provide him the right information. So from there, we started to think about this problem a lot. So if you can close your eyes, you don't have to do this, but if you can close your eyes and just imagine how hard it was to get here, and if you can do that with your eyes closed. And the whole experience of your life now, going forward, navigating to new places, completely blind. It's a very different task. So that's why we created a product called Wayband. So this is a new design that's been implemented. We got accepted into an accelerator program that sponsored us, which was from BMW and Mini, as well as SOSV. They also gave us money, and we gave them some equity. So we were able to develop this concept further on. So we created an app. We created a smart app, a platform that was more accurate than Google Maps, surprisingly enough, because Google Maps doesn't care about walking navigation that much, and they only care about efficiencies. So this is another video I want to play of Marcus Engel, the guy that I met in Pratt 2 years ago, the first blind guy I ever met. I founded the company, and then we moved on from there with my 2 co-founders, and this is now his response using our prototype.
My name is Marcus Engel. I live in Orlando, Florida. I am totally blind. I have been so for 20-something years now. I am an author and professional speaker. I provide lectures nationwide to healthcare facilities and healthcare professionals. I am in a different city or state several times a week. Depending on where I am going, I'll probably use a combination of things. First of all, my orientation and mobility skills. Second, my seeing eye dog, Elliot, here can help steer around objects and help me to make sure that I don't walk down a flight of stairs. When I first started using the device today, I wasn't really sure what to expect. Really ended up turning out to be even better than what I was imagining. The ability to convey information to me just through vibrations and vibration patterns was really amazing. And not only that, but when it wasn't vibrating, it's still giving information that I am on the right path and navigating in the right direction. It was completely intuitive. While I was out using the device, there were 2 or 3 motorcycles that drove by. If I was using my iPhone and the voiceover feature on the iPhone to navigate, and it's telling me, keep going down the block or make a right-hand turn or a left-hand turn, I wouldn't be able to hear that over the outside sound. So I really thought that that was an ability to bring in another one of my senses and be able to navigate with that sense of touch. When I was walking through the park this afternoon, I was able to take in more of my environment with playing on my right-hand side, and there were dogs and families hanging out on my left-hand side. These are things that I was able to experience a little more and pay a little more attention to because I had the device on. If this is a new way of taking in information and it can help a blind person with navigation and orientation, you're really looking at a game changer of a device.
So that was really good. That was really good for us to get that feedback.
My name is...
Oh, sorry. So going back to, why I'm showing you this, we're designers, right? All 3 of us, the co-founders, they have background in mechanical engineering. We have background in fashion, and I've worked at a web design company for a while. I also did stuff with vibration companies, designing new type of vibration called the Gemini Drive, and creating asymmetrical vibration sensations. So these are hard things to do. But in the end of the day, the problem was really the most important thing. And when we're creating a new app, the new AI app, or machine learning-based app, what I want to call it, we want to make sure that it actually helps out the end users. And in this case, for us, it's the blind communities. And eventually, we want the app to be intuitive enough and simple enough that everybody in the world will use our device to navigate. And here's where we are now. Simon Woodcroft is a blind marathon runner in the UK, quite famous. He's worked with IBM and Apple and such, developing their assistive technologies, developing their AI and their computing systems. And he's now partnered with us in order to run the New York City Marathon for the first time as a blind person without a guide. And including myself, I'm also running with him. And so we're doing this, right? 26 miles, there's gonna be a lot of people, we're gonna be avoiding people, and we have to give him and information, macro scale navigation, and it's going to work. So that's our challenge. It's happening November 5th. And these are some of the new partners that we have now. We went through a lot of things, actually, to get here. And Forbes right now is doing a full documentary, a 30-minute documentary on us based on the run. The Skarupke channels has picked us up, and they're going to do a full documentary as well. The Verge is going to be writing an article based on the success of this. And the whole thing with the Skarupke channel has been about AI. They wanted us to do a 90-minute documentary just talking about how are we going to provide them with the right communication. Because when you're blind, everything that you do is verbal. So the new Alexa and all this stuff that's coming out, these are really useful for the blind communities. So we can implement that into wearable devices, of course, and we can now communicate the information through touch. So you can kind of imagine this conversation now you have with technology that's very different. You're not looking at an app that your phone provides for you all the time. So that's the Wayband. That's what we're doing. I kind of didn't talk too much about the AI portion of it because I believe in machine learning as a stepping stone. I've been going to a lot of AI talks, and I think that it's just way more complex than I thought it was. And I'm also an amateur going into it as well. So I did want to kind of do a more in-depth conversation about that in the panel section. And yeah, I can give you some demos in the future if you want. Follow us on Instagram, whatever, I guess. But yeah, thank you so much for coming by, and yeah, thank you.
Thank you, Kevin. Yeah, so I think it might be a time for us to sit down and I guess it's talk amongst us and also audience participation. Yeah, sort of like discussion and Q&A, right? Usually this is the fun part. Okay. I guess I continue using this one. Okay.
Oh, yes, that works. So you use that one?
How was it for you guys?
It's okay.
Is it? Oh, okay. So those are for the audience. Okay. All right. Yeah, just I'm just gonna pick on somebody. Sandra, you're gonna speak next time, but you're also in the audience, so I don't know. Maybe give us some thoughts if you have some.
Hi. It's a little tough being put on the spot like that, but that's okay. No, I think it's interesting seeing all these different perspectives, and it's still hard for me to kind of see. I don't know. I think there's so many applications of AI, and I think it's good to see across the spectrum, even though getting into the details of how each individual uses them, I think requires a bit more discussion. But I do have a question for Francis about how did you, what's your background and how did you get into working with machine learning?
So my background originally, I studied neuroscience in undergrad, but struggled to find work with that degree. So I ended up sort of falling into design and programming. And so I worked at IDEO for 2 years, and then over that time I got really interested in machine learning, especially how it related to journalism, because at the time it was pretty new and there weren't many people working at that intersection. So then I basically left to sort of pursue that, and then I've just been doing it since. Yeah.
Thank you. Do you, just if I can have one more question, do you meet a lot of people working in the overlap between design and AI, or how is that looking to you right now?
Definitely more than a couple of years ago, but still not so many.
Yeah.
So there's still a lot of opportunity there, I think.
There's a question back there.
Hi, I have a question for Kevin. I find your work very interesting, and I'm wondering how specifically are you guys using stimulation to provide direction because it's like very small on your waist, and like how do you do that?
Hello. So that's a great question. So it's really difficult to give you an example verbally when it's based on a touch, information base. That's why we struggle a lot with this. That's why we have to give a lot of demos. But pretty much our patent is based on an orientation of a pie chart. So if you look at it from bird's eye view, we created a pie chart, 360 degrees. We cut out a chunk, and we can change that according to how fast you're moving, to kind of radius curvatures you're going through, whatever. So if you're biking, if you're moving in a fast direction, you can actually make the pie chart a little bit larger, like the area of correctness. So the area of correctness is always off. The motor is completely off. And as soon as you touch the area starting point of you're going the wrong direction, it begins to buzz gently, and then the amplitude increases as you go around the circle. So it's pretty much a virtual compass, and surprising to all of us, right, that this has not been invented yet. So that's why we patent that utility patent for that design. So we came to that solution after a lot of feedback that we got from blind users and children and from people in general. People find the best way to navigate or best way to go through a journey is, when you don't feel anything, when you don't get distracted by anything. So that's why we made the correctness completely off. And then we were creating this virtual corridor, so when blind people are walking in the street, the biggest challenge is to stay on track, because they're always drifting one side or the other. So now we've created this virtual corridor that they're always traveling in a line. And then also, one of the platform that we embedded into the map is these dew points. So pretty much you're playing Pac-Man, and as you go through a radius curve that's tight, or as if it's large, we will create these dew points that pretty much follow along that line. So it's not like Google Maps, like an audio feedback. It says take a right turn or left turn wherever. It's more precise this way. So we pretty much guide them dot by dot.
Okay, thank you. So if as industrial designers, did you guys develop these technologies yourself, or did you collaborate with other experts to do this?
So in the beginning, we did collaborate. I worked with a company called General Vibration, and I specifically worked with him, the founder of the company, for about 1.5 years, developing the Gemini Drive and the Savant, which are very specific, high intense, mass differentiation, and that you can control how fast the mass travels. It's just really intense vibration machines, but they were big and they were very expensive to produce. And when we got into potential production through Texas, it wasn't embeddable into a product yet, and everything that he was looking forward to do was for entertainment, like game controllers, which we are also looking into for the future for VRs and such. But at this moment, we just wanted to make a good impact. So after gaining that experience, I left and I embedded into a potential more higher impact product, like a wearable device for blind people. And that's how we started to miniaturize this kind of concept. So that's the background that we had. Keith also, my co-founder, had a background in doing movement as a suit, movement suit. So he created the array of motors, and that was his idea of trying to convey it in information. But because it's high cost, as soon as you start embedding more motors in, it becomes very difficult. So we found a way to do it with only one motor by increasing the amplitude and the frequency levels, which has not been done in a previous commercial product yet. So that's kind of what we learned.
Thank you very much.
Question in the front here. Oh, over there as well.
Hi, my name is Sonora Weathers. I'm a communications professional. I'm wondering, this is probably more for Kevin, you, but anybody, I would love to hear the answer. Working in communications, what plans or how do you work on building trust of AI technology? Seeing how there's so many people. When I said I was going to an AI event to learn a little bit more about it, my coworkers like, ooh, they got scared. So it seems like there is a public disconnect. So especially for Kevin, you with your technology, you're dealing with a specific demographic, and then anybody else, how are you going to build that trust, as you get into mainstream?
Yeah, I mean, this is literally from the very beginning. We were afraid to go this direction because of that reason. of building trust. It's very difficult. But what I do is I run with them. So every Tuesday, I run with a group called Achilles. They're a collaboration of blind runners and sighted runners. And I run with them using this chat strap that connects me to another blind runner. And we run together through through Central Park every Tuesday at 6 p.m. So that's how the trust is gained, really, right? You gotta run with them. You gotta test the prototypes with them. Everybody's really open-minded if you think about it. In cases of, if you're a blind person, if you're running in Central Park, and if you're dedicating your time to do that, they're quite ambitious and they're willing to try something that's gonna help them. So if you're doing it with them, and if you're testing it with them, and if you give them the trust that that you trust in their feedback as they trust in your product, that's really how you do it. So when I first cold called a bunch of organizations, they have a high barrier up. They're probably one of the highest barrier to break, because they don't want their community being used as experiments and whatever, right? So that's not what we intended. We wanted it to be, hey, we are interested in seeing what you think about our product. We want to develop it with your feedback and you as the foundation, and you create it, and we just help and make it happen. So that's how we got our trust. And people reached out to us after seeing our product going on Engadget and TechCrunch and stuff like that. So once you start picking up this media channel as well, people start trusting you. They read it on Blind New World, and as well as Cool Blind Tech. These articles start popping up, and that's how they trust us. I mean, Simon reached out to us and said, can you build a product for me to run the marathon? And that's when we shifted gears. Instead of going into a mass production for people, we ended up focusing into specifically a blind running product of 100 units, and then going into a higher scale after that. So we're right now focused on getting the trust of the blind running organization specifically, and then we're gonna grow into the blind organizations of general population walking in the cities, and then growing into, so it's a stepping stone.
Oh, actually, sorry, I want to also expand on that same question. I think a lot of time when people don't trust AI, it's because the AI is too much of a black box, where you see the inputs going in, the output coming out, but you don't know how it came to the decision that it came to. And I think the way that you fix that is you just have to make it less of a black box. You have to expose more of the internal workings, or you have to come up with simple models that people can understand, like the pie chart model that he had, where now I can understand how the thing functions, I can work with it all of a sudden. And those things, in AI, it kind of happens a little bit backwards, where, for example, with the neural networks that are now the current hot new thing, we're getting really good results with them in certain fields, but we don't quite understand how it got those good results. And then over the last couple of years, we're getting better and better at understanding how the network actually gets to the results that it has. And then we can understand more how it works, and then we can trust it more for certain applications where we couldn't trust it before. But it kind of, sometimes it works backwards, where you first get the results, and then you have to dig in and see how did it actually get there. And then over the years, you start understanding it better and better. And then, it becomes less of a black box, and then you gain more trust.
Hi, I have thank you so much, everyone. Super interesting question, maybe for the whole panel, in terms of, designers. We're interested in the aspect of generative tools, right? And iterative type of process, where algorithms and even this kind of parametric thinking may provide different possibilities, solutions, options, things that might not even be preconceived designs by individuals. And not trying to take the human aspect of it. I guess what I'm interested in within your experience is, within this type of tool, we're, used to working with the type of statement, the if, else, or utility functions that we can give a certain type of behavior or code or program. And so the results, like you were saying, we know that there's a possibility of results or speculate. But I was interested in your experience, if there's been this type of error, maybe sometimes ethical error, that could be quite interesting, and that could result in troubleshooting, but can also inform real AI, real intelligence, not just parametric or behavior input that we're placing, but that the actual system is providing something that was completely unexpected, maybe through an error. So I'm just wondering if any of you have come across that.
Yeah.
Was that a question?
Yeah, I'm just wondering if any of you have come across that type of error or that type of, unexpected result that is not based on parameters. Because then I think the question of artificial intelligence versus algorithmic or parametric or input-based, design is different, right? Than something that goes back to Henry's definition of intelligence in terms of learning.
Not my definition.
No, I mean the definition that you posed in the beginning.
Yes.
Well,
No, you go first.
well, I don't know if this quite answers your question, but I think something that I think about a lot along similar lines is, so in machine learning, there are, I guess, two main paradigms. One is called supervised learning, in which you provide the machine learning algorithm some data and you tell it when it gets it right and when it gets it wrong, basically. And then there's unsupervised learning, where you just give it a bunch of data and it has to sort of on its own learn the structure and how to categorize things and so on. And I think that's sort of where this potential for these kind of surprising results could really happen. So take, for example, so there's this theorem called the ugly duckling theorem, and it's basically, what it says is that you can't make any kind of categorization without some kind of introducing some sort of bias. So if you think of, like, we have two water bottles here, right? So we as humans would categorize these as water bottles. But if you think about it, there's a lot that's very different about them, right? Not only is their color different, one is opaque and one is transparent and so on, but also their height is different. And we don't think about these things as really being important to distinguishing water bottles. So already we've introduced some bias where these particular differences are unimportant. But a machine, if it looks at sort of raw data about water bottles and their heights and so on, it might sort of learn its own categories and be like, oh, might give this a different name than this or something like that. So these unsupervised learning algorithms are capable of coming up with completely different ways of viewing the world. And I think if you apply this kind of new perspective onto problems that we've seen many times, then you may get some interesting results.
So I think one of the things that you mentioned might merit re-mentioning is that you need a certain kind of bias to simulate or create a new, yes, could you repeat that a little bit?
Yeah, so I guess I'm using bias here in a sense that's not as different than sort of the negative sense of the term. It's more just we have to sort of prioritize some differences amongst others in order to make categorizations. So I could have another cylindrical object, but it may not be hollow, so it can't contain water. But even though these are both cylindrical, one is a water bottle and one isn't. So we're sort of saying the shape isn't as important as whether or not it has a cavity in it or something like that.
So in this case, but you mean bias, you mean prioritized category.
Yeah, like differences.
That's what you mean, yeah. So there are actually like particular bias-based concerns about the data itself being biased. Like, for example, Google frequently mentions that if you want machine learning and AI to be looking at shoes, if you just say, hey, to a lot of people, draw me a shoe or imagine a shoe. Well, people might imagine sneakers or men's dress shoe, but not as many people might be thinking about stiletto high heel. There is a certain kind of expectation that is in the mindset of people who are used to these terms that actually elicit imagery. And those show up in the data. And then these companies, they themselves admit that these are concerns and something to be aware of. So I just thought I'd mention that in the context of the word bias. Thank you.